Guys, welcome back to this week 5, day 1. Today is September 20th, 2021. Remember, you need to leave an empty space and then place the date at the right corner. Before we start solving any practical exercises, we are going to define some words as usual. So we can have that theoretical part, and with that, we will be able to solve exercises. Okay, the first one that we're going to be solving or defining is the word equation. If I say the word equation, what comes to the top of your mind?
Mathematical operations.
I'm sorry?
Mathematical operations.
Okay. Another definition that comes up to your mind? Equation. What do you think when you hear the word equation? Or to what word does it resemble at least? Igor gave us already one definition that he thinks when he hears the word equation. Someone else?
A mathematical phrase.
A mathematical phrase. Okay, that's really big words. What else? Without reading the book, right? Without reading the book, what do you think it is equation? A mathematical phrase or mathematical sentence, that would be correct. But I want something else.
Mathematical expression.
A mathematical expression, okay. But there's several mathematical expressions. A variable expression is a mathematical phrase or a mathematical expression or a mathematical sentence. But what is it? What makes it different from what we have seen already? We saw already variable expressions. And variables expressions didn't have what an equation has. There's one little thing that the equation has that a variable expression does not. And the word equation comes from the word equal, okay? From equal. So that's what the equation has that a variable equation doesn't have. So if we want to really make up definition, it is a mathematical sentence with an equal sign. That's it. It is a mathematical sentence that has an equal sign. So we can say that 2x is equal to 4 is a mathematical sentence. That's an equation. Or we can say, for example, 3y minus 2 is equal to 10. That's another equation. It has an equal sign. Every single phrase, mathematical phrase or sentence that has an equal sign is an equation. You see, it comes from the same word, equation. So it comes from there. Now let's say that it can have fractions. Yes, of course it can have a fraction. It could be 1/2 of d plus 4/3 is equal to 9/5. And you're gonna have to do something more in there because you're gonna have to apply a property of fractions. Okay, you know it as happy face or the butterfly method. Okay, so all of that is a mathematical sentence, which is called an equation. You can also have decimals. And as long as you have an equal sign, then everything is possible, okay? So those are exercises, examples of equations. Now, what is an open sentence? An open sentence is an equation with one or more variables. Why is it called an open sentence? Okay, it is called an open sentence because remember, a variable, it is an unknown value. You remember that definition? We do not know the value of a variable. So that's why it's an open sentence, because there are so many possible answers and some equations have more than one answer, okay? Some equations have more than one answer that make it true. So that's why it's called an open sentence, because it's open to have any answer that you can imagine. You have to solve it in order to find the solution of an equation. And that's our next definition, solution of an equation. So what is the solution of an equation? And I just said it, okay? It is a value for a variable that makes the sentence true or the equation true. So you can have, for example, in here, 2x equals to 4. I can say that the answer for 2x equals to 4 is 5. And you will not be certain that it is actually 5 until you solve it. You need to solve it before knowing if that is the solution of an equation. Okay? And how do we solve equations? Well, we solve equations using what is called an inverse operation. What is an inverse operation? So the definition is an operation that can change, that can undo, okay? That can undo another operation. So it's basically the opposite, okay? So what's the inverse of the addition?
Subtraction.
Exactly, it is the subtraction. And what is the inverse of a subtraction?
Addition.
Addition. And what's the inverse of a multiplication?
Division.
A division. Because you can undo what you just did. So for example, if I say 2 times 2, that is 4. And I want to undo that multiplication, then I go ahead and say 4 divided by 2. It gives me the first 2 that I had, okay? So those are the definitions that we were going to see today. There is one more, okay? And that's the one for exponents. Okay, what do you think it is the inverse operation of an exponent? What do you think is the inverse operation of an exponent?
Miss, I don't remember how to say it in English, but you said it like in the first class.
You can
La
say it in
raíz cuadrada.
Spanish.
La raíz cuadrada.
Okay, the root, okay? Because depending on the exponent, it is the power of your root. So yes, Nino, for example, the inverse operation of a square exponent is the square root. The inverse operation of a cubic exponent is a cubic root. So depending on your exponent is the power of the root that you're going to be seeing. So this is the first part, okay? Now we're going to start solving exercises, okay? I'm gonna start doing them handwritten, okay? So we begin with the examples. We're gonna begin with the easy one. So for example, we begin with x minus 7 is equal to 14. Okay, and I know that you saw this. So x minus 7, that 7 looks like an x. Let's rewrite it. X minus 7 equals to 14. So what do we need to do? And this is when I'm going to give you the steps, okay? What do you need to do to solve this equation? So there are different ways, okay? There are different ways. We're gonna use a different color. We're gonna use green. So steps to solve an equation. Step number 1. Pass using inverse operation. Since we're doing inverse operations, we're doing also inverse PEMDAS. Remember PEMDAS, first you solve parentheses, then you solve exponents. We're not using exponents yet. Then you solve multiplications and divisions, and then additions and subtractions. So we're going to begin with that. We're going to begin passing and using inverse operations, all constants. Okay, that's the first thing. Pass using inverse operations, all constants. Pass it where? Pass it to the opposite side. Of where the variables are. Okay, that's it. So pass using inverse operation, all constants to the opposite side of where variables are. So let's see. We have x minus 7 equals to 14. What constants do you have in this equation? We know this is an equation because it has the equal sign. So which values are the constants 1?
7 and 14.
14 and?
7.
And negative 7, correct. But negative 7 is in one side with the variable x. And the 14 is on the other side of the equal sign, okay? And it is alone. So this 7 that is negative is gonna go to the right side with its inverse operation. So the inverse operation is gonna be? What's the inverse operation?
14 minus 7
addition.
equals 6.
Addition, correct. So we're going to say now x is equal to the 14 that we already have, because we copy always first what we have in there on that side instead of negative. So I say plus, that's why I write it over here so I don't forget what operation I'm going to use. So plus the 7 that I'm doing, okay? So step number 1, pass using inverse operation, all constants to the opposite side of the equal sign, okay, of where variables are. So I'm going to place here in between parentheses of the equal sign. So you don't forget that the equal sign is like the boundary that we're going to be looking at, okay? The equal sign is always the boundary. The equal sign is what lets us know which one is the right and the left side, okay? So that's the first part. Pass using inverse operation, all constants to the opposite side of where variables are, okay? Step 2 will be to simplify. Not always is the right side that you're gonna move constants, okay? Sometimes it is to the left, okay? In this case, it was moving it from the left to the right, okay? So now we're gonna simplify and we're gonna say x is equal to 14 plus 7 is how much? 14 plus 7, how much
21.
is it? 21. And 21 is the solution of my equation. Why? Because, and this is just the proving, which we're not going to be doing right now. If I substitute, like when we were evaluating with x equals to 21, I will have 21 instead of the x minus 7, and this is supposed to be 14, okay? And I subtract 21 minus 7, it is 14. So is 14 equal to 14? Yes, it is. So it is Correct. This is proving an equation. Okay. How many steps did we use to solve this equation? Only one, because we use only one inverse operation. And that's are the steps to solve an equation. But what type of equation? A one-step equation. Okay, so these are the steps to solve a one-step equation. And this is called proof. Okay, this is the proof. This makes sure that you're doing things correct. Okay, I'm not going to ask for you to prove it. However, it is good for you to do so you can see that it is actually correct and that you did simplify in a proper way. So this was simplifying an equation in one step. Let's do another one and let's do it faster, okay? Let's say that I have y plus 1 is equal to 5. Okay, what should I move? And to which side should I move it? Remember, this is the boundary.
The one to the right.
The one goes to the right. And if it's positive, how does it go?
Negative.
Negative, because we use the inverse operation. So we're going to say that y is equal to 5 minus 1. So y is equal to
4.
4. And that's it. That's the solution to your equation. So we solved again an equation with one step, but now subtracted. So we did one added and one subtracted. Easy peasy, right? So I told you, I don't want no proof, but I can do it mentally. So if I say this is 4, so 4 plus 1, 5, yes, it is correct. I can do the proof mentally because I don't need you guys to do it in your notebook, okay? Let's solve another one using multiplications and divisions. These ones are really interesting, okay? So let's say that I have, for example, let's use the one that I gave on the first example, 2x equals to 4. Okay, I'm gonna do this so you can know that this is the example. These are the examples, okay? The ones with a little star. So I'm gonna use inverse operation. There is no constant, okay? There is no constant in there. So I need to have another steps to solve an equation. We're gonna add here, in between the parentheses, adding or subtracting. And I'm gonna add a new step, okay? New steps. So I'm gonna move this to this side and I'm gonna erase this. So step 1, when we are multiplying or dividing. Okay, when we're multiplying or dividing, as you can see, there is no addition. There's no subtraction. And this is only a multiplication between 2 and the variable x. What are we going to do? We're going to pass the coefficient of the only variable to the opposite side of the equal sign using inverse operation. Why do we do that? Because we need to leave the variable alone. So we're going to say in order to leave the variable alone. And then we simplify, and that's it. Okay, and that will be the steps to solve a one-step equation using inverse operations. So the 2 times the x, we're going to pass it to the opposite side to leave the variable alone. So the variable is at the left, we're passing the number, the coefficient, to the right. So the 2 is multiplying. How do I know? Because there's no sign between the number and the variable. So it will go with an inverse operation. And what's the inverse operation?
Division.
I'm sorry?
Division.
Division. Okay. And I told you, we are going to use division from now on as a fraction. So we're going to say that this is x equals to 4 over 2. And now I simplify. How much is 4 divided by 2? There are different ways. You can do it just mentally, or you can go ahead and simplify the fraction itself. Okay, I'm going to show you how to simplify today the fraction itself. So I'm going to say 4 and 2. What number can divide both of them? That is not 1, obviously. I can divide them both by 2, right? Both of them are divisible by 2. So I can say 4 divided by 2, that's 2. And 2 divided by 2, that is 1. And I told you the week before that I do not need no denominator 1. I don't like denominators 1. I just use them when they're needed. But for my final answers, I don't need a denominator 1. So I can say that this is basically equal to 2. This is one way of doing it. The other way was just going ahead and say, okay, 4 divided by 2, 2. And that's it. Now I do the proof mentally, and I go ahead and say, if the x is 2, then 2 times the 2, 2 times 2, yeah, it is 4. So it is correct. Okay. Now, the very last one that we're going to do today is when we are dividing. So for example, I have W over 3 is equal to 6. So W over 3, that is a division. How do I know? Because I told you that fractions are divisions. So I'm just going to pass the number, the coefficient. Yeah, the denominator 3 is the coefficient of the W. And we're going to see it later on. How do we do that also in a different way, but not today. Okay, today we're just going to see this part. So we got W divided by 3. The 3 is dividing, so I pass it to the other side, doing what? It's dividing, it goes. With the inverse operation. What's the inverse operation? If it's dividing, if it's a division, it goes to the opposite side.
Multiplication.
Multiplying, correct. So this is the only way that I'm going to use the x as a multiplication, okay? Because that's how I'm going to remember that that's a multiplication. So I'm going to say, okay, W is equal to the 6 that I have already there. And I'm going to multiply it times 3. And how much is 6 times 3?
18.
18. So we're going to prove it mentally. And we're going to say, okay, 18 divided by 3. Is it 6? Yes, it is 6. And that is how I prove mentally my equations. Any questions so far? This is it. This is what we're going to see today, right now. Okay, no questions. Okay, let's name the topic. What is the topic's name? What's the topic's name?
Equations.
Equation.
Solving
Equation.
equation.
What type of equations did we
Equations
solve?
and variables.
Equation
Solving
of
math.
one step.
Yeah, equations and variables, solving equations. I'm sorry, how
Equations of one step.
equations of one
Inverse,
step or
inverse equation operation.
Oh,
inverse operation, but it is one step equations. Okay, that's the topic's name because we solve only equations in one step. We didn't use no more inverse operations, but one. And that's the name of the topic. One step equations. Tomorrow we're going to continue solving equations. No classwork, okay, but we're going to continue solving equations. Okay, and this is basically the topic for today.